Today we're going to be talking about solving quadratic equations. So you guys have seen this a lot through Algebra 1, Algebra 2, Geometry. I'm sure you practiced it, and now here. Alright, so hopefully remember that the quadratics have this form of ax squared plus bx plus c. And we can use those values to figure out our solutions. So remember that you might hear the term root, solution, zeros even, but all this is really finding is where it crosses the x-axis. So when we think about this, quadratics, we could have two solutions with one quadratic. We could have one solution, and the vertex just touches the x-axis, or we could have no real solutions, which means it never crosses the x-axis. So the first way that you can solve quadratics would be factoring. So hopefully you feel pretty confident about factoring by now and know when you can use it. Now this method does not work all the time because some trinomials you cannot factor. So let's go ahead and jump into this. So with this guy, if we're going to factor it, we need to do our little diamond. We're going to do AC, so it gives us negative 30. Our B value is 1. So two numbers that multiply together gives negative 30, and add up would be 1 would be 5, or negative 5 and positive 6. So now we can make our box. We put our first term here, last term up here, and then we can put 6x here, negative 5x here. So I'm going to start right here. So we can look at those and we say, what is their greatest common factor? And it's a 3. Now I'm going to go next one down. So we say, what do 2x squared and negative 5x have in common? Well, just an x. Now we'll go up. What does 2x squared and 6x have in common? A 2 and an x. And then we have a negative 5 right here. Remember, whenever we're right by the negative, we always pull the negative out. So this factors to x plus 3 times 2x minus 5. So now we've got to take these binomials and set them equal to 0 and solve them. So we have x plus 3 equals 0. Let's go and solve that. So we get minus 3 from both sides, and we get x equals negative 3. There's our first solution. Now we got 2x minus 5 equals 0. So I'm going to add 5 to both sides. Now I have 2x equals 5. Now I'm going to divide everything by 2, and I get x equals 5 halves, or 2.5. So there's our two solutions. So if we were to type this equation in to our calculator and hit graph, we would see it cross at negative 3 and 2.5. So next method would be to use the square root property. So you're going to use square root property when you have something squared. So the x minus p squared equals q. So we would take the square root of both sides if it was that situation. So again, this one doesn't work all the time. This is only for certain types of problems. So we're going to go through and do it right here. So this one, we need to try and get x by itself. So we'd start off by adding 14 to both sides. Now I've got 2 times x minus 5 squared equals 14. I'm going to divide it all by 2. Get x minus 5 squared equals 7. So now we're down to the square. So to undo that square, we have to take the square root of both sides. And we need to put our positive and negative out here on the 7, or the square root of 7, because it has two roots. So we'll move this guy up here. So it gives us x minus 5 equals positive, this is like falling apart on me, positive and negative 7, radical 7. So now the last step would be to add 5 to both sides. So we get x equals 5 plus and minus radical 7. So there's our two roots. So these didn't work out nice and neat. We could, type 5 plus square root of 7 in and 5 minus square root of 7 and get a decimal approximation and make sure that matches up with the graph if we typed it into the calculator. But I'm positive we did that right. So you get whatever's squared by itself, take the square root of both sides, don't forget your plus and minus. All right, the last method that we're going to talk about is the quadratic formula, and I'm sure everybody has used this before. All right, so quadratic formula, we want to make sure we can calculate the value of the discriminant right. So the discriminant's right here. That's b squared minus 4ac that tells us a lot about the type of solutions we have. So if our discriminant is greater than 0, that's telling us that we have two real solutions. So it means it crosses the x-axis twice. If the discriminant is 0, that means there's only one. That means the vertex is on the x-axis. And when it's less than 0, that means it never crosses, so there's no real solutions. There are imaginary or complex ones, but I don't think we're going to talk about that. So let's take a look at this problem here. We can solve this. They want us to solve it using the quadratic formula. So let's take a look at it and see. Now, I don't think we could even factor it if we wanted to. So the first thing I'm going to do is I'm going to calculate the value of my discriminant, b squared minus 4 times a times c. So I have negative 6 squared. Remember, the a is right here, so it's a 1, the b is negative 6, and the c is all by itself, the 7. Minus 4 times a is 1 times c is 7. And what does that give us? 36 minus 28, right? And that should give us what? Positive 8, right? All right, so now the rest of the formula looks like this. We just did the discriminant, so we don't need to write all that in there. So now I'm going to plug everything else into this. So I got negative b. That would make it a positive 6. Coming up here, guys. Plus or minus the square root of 8 all over 2 times a. Well, 2a, a is 1. 2 times 1 is just 2. Now we need to simplify these if we can. So notice that square root of 8 right there. I think we have a perfect square in there, don't we? Isn't 8 the same thing as 4 times 2? And 4 is a perfect square. So we can pull a 2x. The square root of 4 is 2. So I'm going to have 6 plus and minus 2 radical 2 all over 2. And we can again reduce, because notice everything is divisible by 2 on not in the radical on the outside. So we can go 6 divided by 2, and that gives us 3. Plus or minus 2 divided by 2 is 1 radical 2. And that would be our two final answers. 3 plus and minus radical 2. All right, so the discriminant, like I said, can tell us a lot about it. So a lot of times you just need to figure out, what is the value of the discriminant to determine if you're doing it right. So let's take a look at these problems and see what we can do here. All right. So we're going to go A is a 2, B is negative 1, and C is negative 3. So I'm going to go D equals B squared minus 4 times A times C. And I'm going to type us into my calculator, and that's going to give us, what, 25, right? All right, good. So now, since we know it has two real solutions, they want us to find them. So what we could do here is plug it all in. Negative b would be a positive 1, plus or minus the square root of 25 all over 2 times a. A is 2, so 2 times 2 is 4. And the square root of 25 is 5. So we can work this out now. We go 1 plus 5 gives us 6. 6 divided by 4 is 6/4, or 3/2. Then we do 1 minus 5 gives us negative 4, and then negative 4 divided by 4 is negative 1. So that would be our two solutions for this problem. All right, so the next one. So the next one, the A value is a 4, the B value is negative 12, and the C value is 9. So let's plug them in. So our discriminant's going to be negative 12 squared minus 4 times A times C. And we're going to type that into our calculator, and we get out 0. So that tells us we have one real solution. So again, we can use quadratic formula. So we'll go negative b be a positive 12 plus or minus square root of 0, not that we even need to write that down, all over 2a. 2 times 4 is 8. So again, we should be able to reduce this guy down. We can definitely divide them both by 4, right? So 12 divided by 4 is 3. 8 divided by 4 is 2. So this one has one solution at 3/2, or 1.5. All right, so let's do this last one here. So again, we're going to go d equals b squared minus 4 times a times c. And when we work this out, we get a negative 16. So this is telling us there are no real solutions. So this does not cross the x-axis. All right, so sometimes everything won't be on one side. So you're going to have to make sure you kind of know what you're doing here to make your life easier. So if we're going to solve this, we could use, we could try factoring, or we could try the quadratic formula. But let's go ahead and get it equal to 0. I subtract 10 from both sides. I got this. So I'm wondering if there's two numbers that multiply together to give me negative 10 but add up to be 3. And that would be positive 5 and negative 2, right? So now I can go through and set them equal to 0 and solve them. So I'm going to subtract 5. So I get x equals negative 5. And I got x minus 2 equals 0. So I add 2 to both sides. And I get x equals 2. So there's our two solutions. Not too bad. I prefer factoring over the quadratic formula any day. So this one looks like we could use square root property here, right? So what I'm going to do is I'm just going to take the square root of both sides, put my plus or minus there. So that gives me x plus 2 equals positive and negative. Well, square root of 9 is just 3. So our next step would be to subtract 2. Let's get x by itself. So we got x equals negative 2 plus and minus 3. So let's get our two solutions. Negative 2 plus 3 is a positive 1. And then negative 2 minus 3 is a negative 5. So there's our two solutions.